ಇದನ್ನು ಡೈರೆಕ್ಟ್ ಸ್ಟಾರ್ಟ್ ಮಾಡೋದು ಹೋದ್ರಲಿಕ್ಕೆ ಅದಲ್ಲ In that you have seen perform randomized storage and okay, and the inventory level as a function of time, how actually the things, okay, this is inventory level versus the time, okay, graph. In that how the inventory level change according to the time of 50-day cycle. Okay, in that you can see that particular graph, how that particular inventory level increases, okay, and how slowly it is showing the decreasing trend for 50-day cycle time. And again the order quantity of 100 cartons, how it is increasing, okay, and then the depletion rate is equal to 2 cartons per day, okay, that is the sales, okay, and this is the safety stock level, how they are maintaining this particular level of safety stock and average inventory level that they have here you can see, okay, and then comparison of storage strategies we have seen in the last class. Total space, dedicated storage requires space of maximum inventory level and of each item, higher throughput, okay, storage strategy based on activity levels, okay, and the random storage strategy used with within the each class. Those particular thing already have explained in the last class. This is only just a revision for you people. And the conventional storage method you have seen bulk storage, rack system, shelving and bins, drawer storage. Okay, till here I have completed, okay, about the conventional storage methods, bulk storage, okay, and the pallet rack system. This I have explained, drawer storage, okay, and automated. Now from automated storage system, okay, so this actually I'm going to explain, okay, today, that is the automated storage system, okay. So in the automated storage system, okay, this is mechanized and automated storage equipment to reduce the human resources required to operate a storage facility. So usually how you are going to store the material, where you are going to store the material, that is very, very important, okay. And the thing is the mechanized and automated storage equipment to reduce, okay, the human intervention will be reduced because of the automation, okay, because of the mechanization, okay, of how you are going to store the material, either it is the vertical storage system or horizontal storage system, okay. So operate a storage facility, required to operate the storage facility, the human usually the human resource is required, okay, to store the material. Like say you can take the casted part, machined casted part, okay, or the fixtures, okay, the jigs. So after every operation, okay, you are removing the fixtures from the table, you are going to fix. So wherever how you are going to keep those particular fixtures, okay, in the storage, okay, how you are going to store that, okay, because it is a very accurate part, okay, the fixture is a very accurate part, very precise for the precision machining. So how you are going to the store the parts, okay. So, so in the mechanized storage equipment to reduce the human resources, so usually human resources reduced because of this mechanized and automated storage system. Okay. So in the significant investment, the thing here is the investment part. So if you go for the ASRS, automated storage and retrieval systems, so the investment is very high, okay, because of the mechanized and automated parts, okay, and it is controlled by all the PLC programs and all. So mechanized systems are an operator participate in each storage and retrieval transaction, usually so he is storing that fixture, he is retrieving that particular fixture whenever he wants for that particular component, okay. And here the operator participate, usually participation of operator is there for the mechanized foundries, mechanized the systems, okay. And retrieval is, yes, I want to I want that particular fixture, okay, to do some job, the particular job. So each and every fixture has the identification number, and according to the parts, okay, which we can machine on that particular fixture. So accordingly the operator will require that particular part. So here in the mechanized system, operator can retrieve that particular part wherever it is stored, okay, with the identification number. So the operator is required here. He has to participate in each the storage as well as retrieval of that particular fixture. And in highly automated systems, the loads are entered and retrieved under computer control. Usually this is PLC controlled, okay, in highly automated systems, okay, like your horizontal ASRS system or the vertical ASRS system. The loads are entered. Usually either you take the load as the, say, finished castings or other loads, say like your finished products, the product, okay. So you are loading that particular part, you are entering that particular part, and you are retrieving that particular part under the computer control by, see, in the computers you are writing, okay, the identification number is there. So in that particular identification number, okay, with the help of that identification number, you are just giving one number to that particular part, and you are storing that in the shelves, okay, or a bins in the vertical ASRS or horizontal ASRS. Okay, so this is the comes in the highly automated systems. Next, what are the objectives and reasons for automating the storage, the operations? Okay, so there are some reasons, okay, to increase the storage capacity. Now, how you are going to, what are the objectives? Okay, the reasons why you are going for the automation storage operations. So increase the storage capacity. One is the storage capacity you want to increase the storage density. How much part you are going to store, how many parts you are going to store in the ASRS, to recover factory floor space, okay, currently used for WIP, okay, to improve the factory floor space. How you are going to see, because now how intelligently you are going to utilize that particular space. So usually they are going for the vertical ASRS. Factory floor space currently used for WIP, that is a work in process, okay, WIP is work in process. So you are going to effectively you are going to utilize that particular storage systems, that space, okay, for the storage system. To improve the security and reduce the pilferage. To improve the security, yes, you are securing those particular parts by keeping in those particular bins or the racks, okay, in the ASR, automated storage and retrieval system, so that retrieval will be easy and it is safe, okay. Always the product will not say you can't find the product, okay, in the shelves and bins, okay, it is time consuming. So by keeping the identification, by keeping those particular part in the particular rack, okay, and the rack number, so you can retrieve those particular parts easily, and it is secured. The parts is kept in those particular bins only, okay, and reduce the pilferage, okay, and to reduce the labor cost and or increase the productivity. To reduce the labor cost, so it is reducing the labor cost. Say whenever if you want to bring the material, okay, so this is also one of the objective, to reduce the labor cost and increase the productivity. How you are going to increase the productivity? By in the work in process, okay, whenever you required, whenever the changeover is required, like say I want to I have to manufacture 100 number of jobs today, okay, and I want that particular fixture. Once that particular fixture is loaded on the machine table. Okay, once that particular job is over, I require to change over. So whenever you are going for the changeover, okay, it is increased. If you want to increase the productivity, usually if your ASRS is not there, or automated or mechanized, the storage systems are not there, then it is very difficult to enhance the productivity. So if the ASRS is there, then you can directly go and directly take that particular fixture, okay, and directly load on the machine table. Otherwise you have to find, because n number of fixtures were there in the racks and bins, okay, in the conventional methods, okay, wherever you are storing those particular fixtures. But for the second shift operator, this is about the first shift operator. But if you go for the second shift operator, and if you want to change, if the changeover is there, then in that particular case, what is going to happen? He can't change. He can't identify that which fixture he has to load, which is whether it is a first set of fixture, or a second set of fixture, okay, or a third set of fixture, or so and so forth. But the thing is, yes, for the second shift operator, if you go to the ASRS or mechanized storage system, the identification is very, very important, okay. And see, if the identification is not there, then he can't, he will go and search, okay, so it will take time. So in turn it reduces the productivity, okay. And so that is why, to increase the productivity, so that is also one of the objective why we are going for the ASRS system, okay, to improve the safety, okay, as I have told, okay, the components will be safe, okay, the finished component, okay, after say your the machining or your painting operation, if you want to keep those particular products, okay, safely, okay, you can safely keep, okay, in the racks and bins of the mechanized or automated storage systems. To improve the inventory control, yes, to inventory control, yes, how you are going to keep the inventory. Yes, I want today to assemble, so for the assembly operation I want say 100 parts. So how you are going to store those many parts in the bins, okay, 100 parts, every day you have to keep the inventory, okay, every day you are going to retrieve 100 parts, every day you are going to just keeping the inventory level, okay, constant. So that control will be easy in the case of ASRS, because in the ASRS it will show, in the computer it will show how many parts are there in that particular bin. So the inventory control can be improved with the help of automated the storage system. Improved stock rotation, yes, as I have told, how you are going to increase the stock, okay, rotation, how much quantity, as I have told just now, I have told about the inventory control, how many components you have to keep, okay, for the inventory for that particular assembly, okay. If you say one example I want to give is say for the assembly of the engine, okay, say poppet valves, okay, so how many poppet valves are required, okay, so those many inventory we have to keep, okay, in the ASRS system. So that is the improvement, how you are going to improve that, okay, the inventory control. So those many poppet valves, it is manufactured when it comes to the factory and in the storage system, okay, for the next day if I want 100 parts, so how you are going to store those particular 100 parts, and how you are going to keep the inventory of those particular 100 parts, that is very, very important. So that is here to improve, that is also one of the objective, to improve the inventory control. The stock rotation, how you are going to rotate the stock, okay, so the poppet valves, and then again the next shift, again how many numbers are required, third shift how many numbers are required, so stock rotation will be there, okay. That is also one of the objective and reasons why we are going for the automating the storage system operations. To improve the customer service, yes, whenever the customer is there, he is the top priority, okay, whatever the how many components he wants, okay, the customer wants as per his customer order, so those many components we have to produce. So to produce those many components are required. Now those many components are required. Now how you are going to keep the inventory, how you are going to rotate the stock rotation, so to service the customer, that is very, very important. So how you are going to improve the customer by doing all these particular things, okay, stock rotation, inventory control, safety. So with the help of ASRS it is possible, okay, for the mechanized and the storage system and automated storage system it is possible to increase the throughput, okay. So that is the final the objective, okay, to throughput if you want to increase, that is also one reason why we are going for the automation. So here the next types are automated storage system. So types of automated storage systems. Okay, first one is automated storage and retrieval systems. It is ASRS, as I have explained. Rack system with mechanized or automated crane to store and retrieve the loads. So here one important thing is a crane. So to load the component, to unload the component, okay, or to store or retrieve the component, we require the crane here. And the second one is a carousel type of storage system. So here oval conveyor system with bins to contain the individual items. So here this is very, very important, the oval conveyor system, okay, that is required, okay, with bins to contain the individual items. So individual item can be contained with the help of the oval conveyor systems, okay. So ASRS, so this is the figure of ASRS, okay, unit load on pallet ASRS with one aisle. So here you can see this is the storage and retrieval machine, red color one, okay. So it will go inside and it will pick that particular carton box from the storage, and these are having the pallet loads, okay, for the storage model, and this is L by H, that is the height and the length, okay, and these are the pick and deposit stations here. So it will pick and deposit here, okay. So there is a pick and deposit station. So this is the storage structure, okay, the rack framework. So this is the rack framework, whatever it is there. Here this is the rack framework total, okay. So this is the SR machine. Whenever you required, you just move that particular SR machine, storage and retrieval machine, and pick those particular parts and deposit it at the deposit station, okay. So this is the for the unit loads, not for the mass load, okay, unit load systems. So now here these are the types, okay, of the ASRS. The first one is the unit load ASRS, large automated systems for pallet loads, okay. Deep lane ASRS uses for flow through racks and fewer access aisles, and mini load ASRS handles small loads contained in bins or drawers to perform order picking. So usually deep lane ASRS, okay, uses flow through racks and fewer access of aisles, okay, deep lane ASRS. So unit load ASRS, large automated system for pallet loads, that I have just now we have seen that unit load ASRS. So deep lane ASRS is a flow through racks. Usually it is a flow through racks and fewer access of aisles, okay, very few aisles were there. Mini loads ASRS handles small loads, usually very small loads it can contain in bins and drawers to perform order picking, okay. So that is called the mini load ASRS. Man on board ASRS is a human operator. One operator is required, okay, to perform that particular operation of loading and unloading. So human operator rides on the carriage, okay, to pick individual items from the storage. So usually picking and dropping. See, same thing you can see these type of ASRS in the Tata Motors or Mahindra and Mahindra assembly line. You can see the storage. They have the big storage system, okay. So to bring that particular the engine, assembled engine to the assembly station, okay, for the car manufacturing assembly, okay. So there we can see these type of man on board ASRS, okay, and the automated retrieval systems, okay, vertical lift storage models, those particular things we can see, okay. Man on board, human operator rides on the carriage, okay, so to pick individual items from the storage. And automated item retrieval system picks individual items. So whatever the items are required for the assembly, so those particular items wherever we are storing, so it will pick, automated item retrieval system will pick and it will keep those particular parts in the storage, okay, system. Vertical lift storage modules, VLSM, this is also called as a VLSM, uses a vertical aisle rather than a horizontal aisle as in the other ASRS type. So if you see the other ASRS, it is a horizontal aisle, but here it is a vertical aisle. So that's why it is called vertical lift storage module, okay. So next, what are the applications of the automated storage and retrieval system? So usually if you see the ASRS applications, okay, unit load storage and retrieval, warehousing and distribution operations. So usually the automobile have that big warehouse, okay, warehousing and distribution center. If you see the distribution centers and warehouses wherever we are keeping mass, okay, items like say your engines, whatever they say, usually I have seen in the car manufacturing daily they are manufacturing around 800 cars. So total number of items for to manufacture those particular 800 cars. Okay, those many thousands of items will be there. Okay, to manufacture that particular car. So those particular 1,000 items or thousands of items where you are going to store. So warehouse is required. So unit load storage and retrieval system where we are seeing that application in the warehouse. Okay, where we want to keep those particular part and store the part, and we are retrieving the part. Okay, so warehouses are required. Okay, dedicated warehouses are required. Distribution operations. Okay, and distribution. So we want to distribute those particular part to the different departments, like say assembly department, assembly line. Okay, or other this thing. Okay, departments. So usually these particular unit load storages are, we can see. Okay, ASRS types, unit load, deep lane. Usually we can see these particular parts in the food industry. Okay, so unit load and deep lane ASRS. Next, second application is order picking. So first one is unit load storage and retrieval. Second one is the order picking. So usually in the order picking, okay, so ASRS types are mini load, man on board, and item retrieval type. So this is for the order picking. So wherever the parts are stored, okay, I want to pick those particular parts. Okay, what are the different types of the ASRS we are using for this type of application is the mini load ASRS, man on board ASRS, and item retrieval type of ASRS. Next is third one, the work in process storage. So work in process storage helps to manage WIP in factory operations. So usually the factory operations, how you are going to keep the after, okay, some machining is done, okay, where you are going to keep that particular part, or else what we are calling it as a work in process. So helps in manage the work in process. So it will manage, okay. So it depends on the cycle time of individual machines. Okay, if I want to keep after one part, for the first process operation we are using one machine, second process operation we are using second machine. Now first operation, after first operation is over, how you are going to keep those particular parts. Okay, if the cycle time, say for the first machine it is say half an hour, and for the second machine, okay, it will take around 45 minutes time. So how you are going to keep that particular part, okay, after first operation, where you are going to keep the part in the work in process. So to manage that particular work in process, we require this particular type of the ASRS, automated storage and retrieval system. Okay, then buffer storage between the operations with the different production rates. As I have told just now, I have explained about this. Okay, work in process and different production rate of production. RP, rate of production, is depends on your average production time. So average production time, how you are going to calculate? So usually average production time is calculated using, so whatever the tool changing time is there, that is a tool loading and unloading, okay, cutting tools in the machine, and then the operation time of the machine, loading time of the component, and then total quantity and your non-operation time. So that gives the average production time, and if you go for the rate of production, it is 1 divided by TP, okay, the total production time, average production time. So here buffer storage between the operation time. So I have told just now, I explained that the two machines we are using and work in process we are keeping. So how you are going to manage that? How you are going to manage that storage? Okay, that is a buffer you are going to keep in between each machine. So say in the operation we have 5 machines, and in between the one machine we are keeping the buffers. If something happens to the machine number 2, if something breakdown happens, or if something say parts, the cutting tool wear will be there, wear out happens, in that particular case we are just stop that particular machine and we are removing that particular part or a cutting tool from the adapter, okay, or a spindle, and then we are just to go for the resharpening, or we are loading another new tool. So in that particular case we are using the buffer storage in between the machines. So between the operations with different productions. So if the machines have different production rates, so in that particular case we are using this work in process storage. So buffer storage between the operations. Next is supports the just-in-time manufacturing strategy, because just-in-time is very, very important as far as the manufacturing is concerned. If you want to increase the productivity, yes, you have to do those particular parts, manufacture those particular parts in just-in-time using the just-in-time manufacturing strategy. Okay. Next is kitting of parts for the assembly. So whenever you are going for the assembly, okay, see in the, I'll just give one example of for this particular the point. Okay. So if you go for the assembly line, okay, that I have seen in Tata Motors. Okay, this particular how they are kit those particular parts. Okay, kitting means for that particular assembly how many parts are required. So those many parts you have to bring with the help of kitting. Okay, so kitting of parts for the assembly. So you have to bring all those particular parts in that particular station, and you have to assemble one by one. So that is called the kitting of the assembly, kitting of parts for the assembly. So that is in the work in process storage. So this is work in process storage. This is the third application. Okay. Next is corrosive system. So usually in the corrosive system, horizontal corrosive or vertical corrosive system is there. So operation is similar to overhead conveyor system used in dry cleaning establishment. Usually this is one example of dry cleaning establishment. So usually if you go for the other examples, like if you want to go for the painting operation, okay, that is the surface coating operations. Okay, in that we have a nitriding operation, okay, blackwoodizing operation, or epoxy painting operation. So different operations will be there. So this is also one type of operation, dry cleaning establishment. So I'm giving the 2-3 examples of that. So operation is similar to overhead conveyor. So for that, to bring those particular things, the overhead conveyor system is required. Okay, with the help of the hinge and all. So that particular thing, that is a horizontal, comes under the horizontal the corrosive storage system. Items are stored in bins suspended from the conveyor. So usually it is stored, small parts are stored in the bin, big parts we are just using the hooks, and then we are just dip. If you want to go for the blackwoodizing operation, what they are doing, they are just clamp that particular part to the hook, and then they are just lowering that particular part in the chemical, and then again they are taking back, okay, after that particular operation. So that is called the blackwoodizing operation. So items are usually the small items. If you go for the small items like say dowel pins and other parts, they are keeping those particular parts in the bins, and then they'll just lower that particular part in the chemical, and then they'll keep those parts for some time. Okay, it depends on the cycle time of that particular operation. Okay, so the blackwoodizing process. So accordingly, and then they will lift that particular bin from the. So this is called the overhead type of conveyor system. Okay, and in the painting also, okay, they will hook that particular part to the painting, and then they will go for they will go for the spray painting or the other type of painting process. Okay, so length ranges between 3 meters to 30 meters. Usually that horizontal the storage system, corrosive storage system, the length is in between 3 meters to 30 meters. And horizontal is most common type. Usually in industry they are using this type of the corrosive system. Okay, horizontal corrosive storage system. So vertical corrosive storage system, second type, operates around a vertical conveyor loop. So usually vertical conveyor loop is there, and then it will operate like this. So vertical conveyor loop. Let's go here. If you go for the horizontal type of the corrosive storage system, it requires more space. Okay, if you want to reduce the space, okay, floor space, then you have to go for this vertical storage system. Storage system you have to go. So, but the overhead room should be provided for this type of corrosive system. So this is the horizontal corrosive system, storage system. So manually operated horizontal corrosive storage system. Here manually operated. Okay, conveyor system will be there. The component will come. This is load and unload station. Okay, from where we are going to load and unload. So this is the corrosive. If you see this particular green color one, okay, this is the corrosive track. Okay, and this is the drive motor system. So it will move. Okay, in the around the rack. This is the corrosive structure. Okay, this is the structure of that, and then these are the bins. Okay, these are the bins. Okay, and this is a stacked type of thing. Okay, wherever you are keeping those particular parts, whenever you want to retrieve, okay, you can retrieve those particular parts from the corrosive system. Okay, and you can store those particular parts also. The application again, the corrosive systems are the first one. the storage and retrieval operations. Okay, in that the order picking, kitting of parts for the assembly, as I have explained. Okay, and similarly, whatever the ASRS applications are there, similar type of this thing, storage and retrieval operation, order picking, kitting of parts for the assembly, transport and accumulation, progressive assembly with assembly stations located around the carousel. So usually around the carousel, they will keep that particular assembly station, so that the order picking will be easy and the kitting of parts for the assembly will be easy. So that is called the transport and accumulation, to reduce that transportation. So usually the assembly and storage assembly stations located around the carousel. Okay, for the progressive assembly. Work in process applications in electronics industry are common, usually for the electronics industry, like your mobile phone assembly stations. Okay, so usually work in process. So this type of carousel are used for the work in process operations. Unique applications. So usually if you see the work in process operation for the WIP, work in process, WIP, the applications in electronic industry, if you see even electronic industry, like your mobile phones, if you take the smartwatches, okay, so usually how they are going to assemble all the parts. So usually they will make the kit of those particular parts, and individual stations, whether it is the carousel type of thing or the rotary conveyor system, rotary carousel system. Okay, after one station, every station they'll go for the assembling of different parts. Okay, say if I give the smartwatch, okay, the casing is the first important thing. Second thing is the buttons. Third one is the outer this thing. Okay, the belt and your case. Okay, so individual stations, they are assemble all those particular parts. Okay, and the glass, all those particular things. So that is a work in process. How many parts they have to keep in the storage, okay, or a buffer. So in the work in process, continuously those particular parts we have to feed. So usually in the assembly stations, that's why in the progressive assembly systems we have to go for, we are just going for the assembly stations located at the carousel type, carousel, near the carousel. Okay, and unique applications, example, time testing of electrical products. Okay, time testing of electrical products. So if the switch gear is there, so time testing of that particular switch gear. Now how they are going to do? So that is one unique application. So for that, these particular carousel type of the storage systems are required for those the electrical products. Okay. These are the engineering analysis of automated storage system. Automated storage system sizing of the ASRS throughput analysis. So with the help of these two, sizing of the ASRS and ASRS throughput analysis, okay, we are going for the automated storage and retrieval system. That is the engineering analysis. Okay, what we are doing. And carousel system. So second time, storage capacity. How much is the capacity of that particular storage? And then throughput analysis. Here also throughput analysis, and here also throughput. How much we are going for throughput analysis? How much will be the throughput? That we are calculating. But in the automated storage and retrieval ASRS, we are mainly the engineering analysis we are doing on the sizing of that particular ASRS. Vertical ASRS or horizontal ASRS. But here, what is the capacity of storage capacity of that particular the carousel system? Okay. So this is about the carousel system. Okay, horizontal carousel and vertical carousel system, or a storage system. Okay, so this is about the vertical ASRS or horizontal ASRS, okay, or the carousel systems. Okay, these are the things. Okay, so now after this is the fifth chapter what I want to explain today. Okay, after the second chapter, whatever the chapter is there, this is about the inspection technology. So usually in this particular section, okay, of the inspection technology, okay, usually why we are going for the inspection, why inspection is required, okay, what are the fundamentals of inspection. So those things we are learn in this particular topic, okay, unit. So the sections include the fundamentals of inspection. This section include the fundamentals of inspection. Second one is automated inspection, okay, and the third one is contact and non-contact type of inspection, and the fourth one is a coordinate measuring machine. Fifth one is the surface measuring measurements, and sixth one is the machine vision. Seventh one is the other optical inspection methods, okay, and the eighth one is the non-contact, non-optical inspection techniques. So these are the eight sections you are going to, subsections you are going to learn in this particular inspection technology. What are the fundamentals of inspection? Okay, usually there are four types, okay, in the fundamentals of inspection. The first one is the types of inspection. Second one is the inspection procedure. Okay, what is the procedure for the inspection? Third one is the inspection accuracy, how much accurate it is you are doing the inspection. And then the fourth one is the inspection versus testing, how you are going to inspect that, how you are going to test that. Okay, so these are the four fundamentals of inspection. So the types of inspection. So usually the inspection of variables. In the types of inspection we have two again subsections. One is the inspection of variables and second one is the inspection of attributes. So first, inspection of variables. In that, in which one or more quality characteristics of interest are measured using an appropriate measuring instrument or a sensor. See, more quality characteristics of interest. So if I want to measure the diameter of the cylindrical part, the more quality characteristics of interest is the diameter. Okay, so that is measured using an appropriate measuring instrument. Say measuring instrument is your digital vernier, dial vernier, or regular vernier caliper. Okay, or a sensor based system. Okay, so that is the characteristic. Okay, that is inspection of variables. If I want to measure the dimension, okay, of the say some block, okay, the prismatic component, so length, width, height of that particular component using say different the measuring instrument, okay, say like your digital height gauge, okay, or else the depth vernier. So the different instruments are there. So that is your variables, okay, the length, width, height, okay, or a diameter, okay, or the other type of the variables, okay, we can use using the measuring instruments. We can use those particular parts. Yeah, again, if the quality characteristics of the interest, say if the quality characteristics, say if I want to measure the diameter, okay, if the tolerance is given within some say 20 micron and more, then we are usually we are going for the vernier calipers, okay, because the least count is 20 microns. Okay, if you go for if the least count is given, like if the tolerance band is given within 0 to 10 micron, then we can't use that particular measuring instrument, vernier caliper and other digital vernier caliper, because the least count is 0.02. Okay, 0.02, yeah. And if you go for if it is less than 20 micron, then we have to go for the micrometers to measure the diameter. Okay, or we have to go for CMM. Okay, coordinate measuring machines. The inspection of attributes, usually in which here the part or the product is inspected to determine whether it conforms to the accepted quality standard. So usually how the part or a product is inspected, the part after machining, okay, if the part using the go no go system, okay, we are going to accept. If it is acceptable, then it is a go. If it is if it is not going, if it is answering in the no go system, then the part is rejected. So the part after machining, we are checking with the help of go gauges and no go gauges, okay, or what we are calling it as the quality confirmation, okay, to confirm the quality, to accepted the quality standard, okay, whatever the standard or whether the part is given, okay, with the help of the tolerance, whatever the band is given for that particular part. If it is confirming, then we are accepting that particular. If it is non-confirming, we are rejecting that particular part. Okay, so that is the attribute. Okay, that is for the part or the product. Okay, in the assembly, that's why that in the assembly that is very important. If the part is not confirming, okay, it will take time. The productivity decreases. So that's why always they are checking with the help of these particular methods, confirming methods like say go and no go gauge. They will check. They will if it is entering, if it is answering go, then they will accept. If it is not answering, then they will reject that particular part. Okay, so that is according to the quality standard. The determination is sometimes based on the judgment of the inspector. Usually determination, so it depends on the judgment of the inspector, okay, because the tolerance depends on the tolerance band, because he didn't know about that particular, whether it is a sliding fit or the interference fit, everything. See, in the drawing everything is specified, but if it is a sliding fit, he didn't know whether that particular part is of 20 micron or 25 micron tolerance or 30 micron or 28 micron tolerance. Okay, gauge, he knows about the gauge, okay, upper limit and lower limit, and the part upper limit and lower limit. But whether it is answering or not, yes, that decision is the determination of is sometimes based on the judgment of the inspector. Okay, whether we have to confirm it or non-confirm it. In other cases, the inspector uses the gauge to aid the inspection. So whether that particular part is okay or not, okay, visually he can see, or he can use the go and no go gauge for that particular part to inspection, for the inspection. It also involves counting the number of defects in the product. Okay, so counting of the defects, number of defects in the product. With the help of that, he is inspecting the attributes. Okay, this is the inspection of the attribute. So these are the inspection for variables and inspection of attribute. Okay, so example of inspection of variables and examples of inspection of attributes. So these are the things what is there. Okay, the difference. So first difference is inspection of variables, in that measuring the diameter of a cylindrical part. Okay, that is the first inspection of variable. That is the diameter of the part, as I have explained just now. I have explained that. So here example of inspection of attributes. Okay, gauging a cylindrical part with go or no go gauge to determine if it is within the tolerance limit or not. Same thing I have explained just now. I explained that also gauging is required. Gauge is required to determine, okay, whether it is within that tolerance limit or not. Okay, if it is given the 0 to 50 micron tolerance for the part, whether it is in that particular tolerance or not, for that we are using go and no go gauge, okay, to determine whether it is in the limit or not. Measure the second one, measure the temperature of toaster oven to see if it is within the range specified by the design engineering. So toaster oven temperature, okay, measure the temperature of the toaster oven within that specified range or not. Okay, so that is the variable. Again, the temperature is the variable here. Inspection for the attributes, determine the fraction defect rate of a sample of product parts. Sample defect rate, okay, fraction defect rate. So how much defect rate is there? Fraction defect rate of a sample of a production part. How much it is acceptable, how much it is rejected, determining that fraction defect. So that is the attribute, comes under the attribute. Next is measurement, measuring the electrical resistance, okay, of an electronic component, measurement of the electrical resistance. So here the variable inspection for variable is the measurement of the electrical resistance, okay, that of an electronic component. So that will come into this particular inspection of variables. Okay, measurement of that electrical resistance. Okay. Now here in the inspection of attributes, counting the number of defects in an automobile as it leaves, okay, the final assembly part. How many defects are there? Okay, counting the number of defects in an automobile. Okay, so as it leaves the final assembly plant. So usually that's why in the assembly line, okay, how many parts are required? That's why we are maintaining the work in process. Okay, we have to that's why, as I have just now I have explained in the vertical ASRS and horizontal ASRS and corrosive system. Okay, those many parts are required. How you are going to store that particular part, storage capacity, everything. So but here counting the number of defects, okay, after that, yes, we are checking all those particular parts and we are keeping into the ASRS, and whenever we require we are retrieving that. But counting the number of defects in the automobile as it leaves the final assembly part. So it has to leave for the final assembly. So we have to check all the parts, okay, before keeping those particular part into the storage system. Okay, so we have to count number of defects. So that is also one of the attribute, number of defects we are checking. Okay, counting. Measuring the specific gravity of a fluid chemical product. This comes under the inspection of variables. Okay, measuring the specific gravity of a fluid chemical product. Okay, specific gravity is the variable. Okay, inspection variable here. So gravity of the fluid for the chemical product. So that is comes under the inspection of variables. Next, example of inspection of attributes. Okay, counting the number of imperfections in a production run of carpeting. So imperfections. Okay, carpeting. Whenever you are weaving that particular carpet, okay, in that how many imperfections are there? Okay, that counting of imperfection is also one of the attribute, inspection attribute. Okay, in the inspection. Okay, so this is the inspection of variables versus inspection of attributes. So this is the thing. Okay, today I'll stop here. Okay. So in the next class, okay, next class I will explain about the contact and non-contact type of inspection technique. Okay, in the contact and non-contact type of the method. Okay, you will learn contact inspection techniques. Okay, and then non-contact inspection techniques. Okay, so these are the two types in the non-contact inspection technique. Also, you will learn optical, non-optical type of non-contact inspection techniques. Okay, and in the PQ chart indicating most appropriate measurement equipment as a function of parts, variety and quality, that we are using part variety and part quantity with the help of CMM and other coordinate measuring machines. Okay. So conventional measuring inspection and coordinate measuring machine. Usually in this contact type of inspection, we are using this, or 2D inspection, what we are calling it as a TRIMOS, or TRIMOS is a company name, but usually for the 2D inspection, CMM is a 3D inspection. But if you go for the 2-dimensional inspection, we are using the micro height, what we are calling it is a micro height gauge for 2D inspection. So TESA micro height, TRIMOS. So these are the manufacturers are there in the leading manufacturers, and the pioneers are there in the 2D measuring instruments. CMM like LK and other, the Mitutoyo is there, TESA is there, TESA Hexagon. They are manufacturing these particular CMM, accurate within 1 micron accuracy or repeatability. They are giving those particular products. So for contact type of inspection. Okay, so this is about the contact versus non-contact inspection technique that you will learn in the next class. Okay, so today I will stop here. Okay, in the inspection technology. So today I will end this particular session. Okay, with this particular note. Okay, so tomorrow contact versus non-contact inspection technique, and conventional measuring gauging techniques. Okay, coordinate measuring machine. These are the 3 topics. Okay, subtopics I will cover in the next class. Okay, so thank you very much.